Okay, so our next lesson on the Earth's atmosphere, and don't worry, you haven't missed a lesson. I did 13.1 and 13.2 together in that first lesson. 13.2 was about the carbon getting locked into rock and the atmosphere being transformed over time. So I want to talk today about greenhouse gases. So we're just going to there's a diagram here which I've put up on the whiteboard there. That's a PowerPoint. I've included the PowerPoint in the package of resources on Satchel. But fundamentally have this idea where that's the atmosphere there, and that's the Earth's surface. So we have the sun here. Here's the sun. And the sun is sending rays of electromagnetic radiation towards us all the time. And some of that radiation actually gets stopped by the outer layers of the atmosphere. We talked about the ozone layer in the last video. The ozone layer protects us from harmful UV rays coming at us from the sun, sometimes called UVC, the highest energy UV rays. But most of that heat comes in and reaches the Earth's surface, and a lot of it, of course, gets kind of soaked up by the Earth's surface. It warms us up, right? And we can all picture going out on a really hot day of the summer, and maybe you're barefoot. You walk barefoot on the beautiful white sands of Wirral Beach, and there's that's the heat. You can feel it in your feet, or even better, walking on nice fresh black tarmac on a hot sunny day, and that real intense heat because the Earth has absorbed that heat. So we've got high energy radiation or ultraviolet radiation from the sun. And something to bear in mind about ultraviolet radiation, it's the higher energy end of the electromagnetic spectrum from visible light. That means it's shorter wavelength, higher energy or higher frequency radiation coming at us. And then we mentioned that the Earth's ozone layer protects us from the most harmful UV radiation. Okay, so that heat from the sun, that radiation from the sun warms the Earth's surface. Well, what happens then? Well, the sun goes down, it becomes night, and of course the streets, the sandy beaches become cool again. They become cool because that Earth is radiated back out into space. And again, you can probably imagine a winter night, beautifully clear. There's a lovely icy moon up in the sky, a lovely set of stars. It's those nights when we have no cloud cover in the winter that temperatures really drop. And that's because the heat is escaping straight out into space. When we get lots of cloud, that actually traps the heat, keeps it in. So some of that heat from the Earth here is going back out into space, and you probably know from looking at videos of cops trying to track down the criminals in the middle of the night. And they use these clever infrared cameras, and the criminal's running away, so he's very hot. So he shows up as a big hot white blob on the infrared camera. So the heat is radiated from this hot object, the Earth, as infrared radiation. So infrared radiation is of a longer wavelength than visible light, and therefore it's lower in energy, lower than ultraviolet light. Okay. So a lot of that heat just goes back out into space. You know, as we all know, it gets colder at night, but some of that heat is trapped by the Earth's atmosphere. So some of the infrared radiation being radiated back out into space is trapped by the so-called greenhouse gases in the atmosphere, for example, carbon dioxide and methane. So we have this image of a greenhouse, yeah, which, you know, like the one you have in your garden. The sun's energy comes in through the windows, but then it can't get out through the glass. It's a slightly different type of heat. Of course, it's convection currents that can't escape, but we understand the principle. The Earth is heating up, and then that heat can't escape back out into space. Okay, so that's a good thing, as I will say shortly in the thing there. There's some notes there on the PowerPoint. If you miss any of them, I'll include that, as I said, as part of my package of resources on Satchel. Those greenhouse gases have been there for millions of years, and we need them to stay there for millions of years. They keep the Earth's temperature warm. If we didn't have any greenhouse gases in the atmosphere, all of that heat would escape back out into space, and the Earth would just be a big solid ball of ice, and we'd all die. So we need that small amount of greenhouse gas there to keep the Earth reasonably warm. The problem is we've been adding to those gases for quite a long period of time now, 150 years since the Industrial Revolution, since we started burning fossil fuels, and that's now causing us a problem. But I'll talk about that in the next video.